If you've been watching the news lately, you know we are living right in the middle of an absolute AI revolution. But what's actually driving it under the hood? Well, welcome to this explainer. I am so thrilled to have you here today because we are going to completely demystify the technology that is powering today's artificial intelligence. And honestly, the best part? We're going to do it by focusing on the core concepts zero dense math required. Okay, let's dive into this. Have you ever wondered why tools like ChatGPT and Gemini seemingly achieved this massive leap in intelligence overnight? I mean, it felt like one day computers were struggling to understand a basic voice command to set a timer, and literally the next day, they're writing poetry, passing the bar exam, and coding entire websites. Like, how did that happen? What actually changed? There is a quote that I think captures this perfectly. The transformer did not simply improve artificial intelligence, it fundamentally changed how machines learn from information. Back in 2017, researchers at Google dropped a landmark paper called Attention is All You Need, and in it, they introduced a totally new architecture called the transformer. Guys, this wasn't just a software upgrade, it was a total paradigm shift in deep learning that made literally everything we see today possible. So, here is our roadmap for this explainer. We'll start with the problem with early AI, then uncover the power of attention, and peek inside the transformer engine itself. After that, we'll break down BERT, GPT, and T5, and finally, look at the future of AI. Section 1. The problem with early AI. Sequential bottlenecks. To really appreciate the transformer, we first have to understand the bottleneck of older AI models, things like recurrent neural networks, or RNNs. RNNs process data sequentially, which means they read one single word at a time. Imagine trying to read a 300-page book this way. You read page 1, then page 2. By the time you hit page 280, if someone asks you a question about page 1, you're relying entirely on this really fragile sequential memory. It's so easy to forget details over long distances, and because it's word by word, training it is painfully slow. But the transformer, it uses parallel processing. Instead of step-by-step memory, it instantly opens the book and reads the entire sequence at once. It's way faster, it scales beautifully, and it never loses that context. Section 2. The power of attention. Solving memory limits. So you're probably wondering, how exactly does the transformer process all that information at once without just getting totally overwhelmed? Well, the secret sauce is a mechanism called self-attention. Self-attention allows every single word in a sentence to examine every other word simultaneously. Think of being in a really noisy classroom. If someone shouts your name, your brain instantly tunes out the background chatter and zeroes in on that one voice, right? Self-attention does the exact same thing for words. If the AI reads, "The cat sat on the mat because it was soft," how does it know what it refers to? Self-attention lets the word "it" scan the entire sentence, tune out the noise, and connect directly to the word mat, because soft is strongly related to a mat. But here's the kicker. This isn't just for writing text, because self-attention analyzes long-range relationships instantly across an entire sequence. It is literally revolutionizing real-world science. Take wildfire prediction. A transformer can look at hours of environmental data all at once and instantly connect, say, current bad air quality to a shift in wind direction that happened several hours ago. Or look at sports biomechanics. Instead of analyzing a video frame by frame, it looks at the entire walking cycle simultaneously, connecting a heel strike at the beginning of a step to knee flexion at the very end to instantly spot a gait abnormality. That's just wild. Section 3. Inside the transformer engine. Under the hood. Now, what's really interesting about this concept is how the AI actually figures out what to pay attention to. It all boils down to 3 simple vectors that every single word generates: the query, the key, and the value. Q, K, and V. Think of it exactly like walking into a massive library, but, with a much better search system. The query is your search topic. It's asking, what information am I looking for? The key is the title on the spine of the book. It's saying, here's the info I have. And the value? That's the actual content inside the book itself. The transformer simply compares every word's query against every other word's key, and when it finds a strong match, it grabs the value. It is just an incredibly elegant way to filter for the most relevant information. But the engine does have a few more crucial parts. Because transformers read everything at once, they use something called positional encoding. This basically attaches a number to each word so the model doesn't lose the order of the sentence. Then you have multi-head attention, which is kind of like having multiple brains looking at the text at the exact same time. So one head is looking at grammar, another is looking at cause and effect, and so on. All of this happens inside the encoder,
which understands the input, and the decoder, which generates the output. And there's a really vital detail here. The decoder uses masked self-attention. Basically, it puts a blindfold over future words so the model can't cheat and peek ahead at the answers while it's generating a response.
Section 4. BERT, GPT, and T5. The big three.
An incredibly important realization researchers had was that not all transformers actually need both the encoder and the decoder. You can split them up based on what you want the AI to do. And this brilliantly illustrates the big three architectures. Take BERT, for example. It's an encoder-only model. It reads in both directions simultaneously, which makes it an absolute powerhouse for understanding and analyzing existing text, like classifying thousands of reports. Then you have GPT, which is decoder-only. It reads left to right and is an absolute master at predicting the next word, which is why it's the engine behind generating text and chatbots. And finally, T5. It uses both the encoder and the decoder, so it's perfectly designed for converting text, making it the reigning champion for things like translation or summarizing a massive article into a short paragraph.
So, we've spent a lot of time talking about language, but I want you to consider this really profound truth. Transformers were originally built for text, but they absolutely did not stop there.
Section 5. The future of AI. Beyond language. The mathematical brilliance of the transformer, that ability to look at a whole sequence and understand the relationships within it, has become the foundation for virtually all modern AI. Look at how this adapted. We now have vision transformers. Instead of processing an image pixel by pixel the old way, a vision transformer chops an image up into small, square patches and treats each patch exactly like a word in a sentence. It uses self-attention to understand the whole image at once. This paved the way for multimodal AI, where a single model processes text, images, audio, and physical sensor data all at the same time. This is literally the exact technology powering medical image diagnosis, the brains inside autonomous cars, and how real-world robots navigate their environments.
Let's move to and see how this builds into the systems we actually interact with every day. It all starts with pre-training, where the model reads massive data sets just to learn general reasoning. Then, through fine-tuning, it becomes a specialist, like a coding assistant or a medical aid. But here's where it levels up. With Retrieval Augmented Generation, or RAG, the model can actually search external databases in real time to fact-check itself before it speaks. And the ultimate evolution? AI agents. This is where the model stops just passively answering questions and starts taking action. It plans, uses tools, browses the web, and executes multi-step tasks to actually achieve a goal. If you take away just one single thing from our explainer today, let it be this. A transformer is the mathematical engine. It's the Q, K, and V, the self-attention. A large language model, or a multimodal AI, is the fully built car. It is the massive trained intelligence system that harnesses that engine so you and I can interact with it every single day. Which leaves us with a fascinating and maybe slightly provocative question to end on. We've seen how attention allows these models to perfectly understand language, images, and physical space. As AI agents gain the ability to take autonomous, real-world actions across all these different modalities, what will they choose to focus their attention on next? Thank you so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.